parts, what I'm going to look at in this video is something called connected quadratic equations. Okay, the first part of this example, solve for x, and it gives me a quadratic equation, straightforward enough. So my quadratic is x squared minus x minus 6 equals 0. Okay, so I can solve this using guide number, using trial and error, using minus b, however you're most comfortable. I'll just do guide number very quickly. So my guide number here is minus 6. Just write down the factors of 6, 1 and 6, 2 and 3. My guide number is negative, so I've got I'm looking for one positive and one negative factor, and I'm trying to make minus 1 here, so plus 2 and minus 3. Plus 2 multiplied by minus 3 is minus 6. 2 minus 3 is minus 1. So that's what I'm looking for. So that's 2x minus 3x minus 6 equals 0. And then an x squared at the start. So I've got two groups of 2 there. So x squared plus 2x, just factorize x out. So x on x plus 2 minus 3x minus 6, factorize minus 3 out, because I'm looking for a positive number in there, so I'm going to factorize the negative out to get positives inside the bracket. So minus 3x divided by minus 3 is x, minus 6 divided by minus 3 is plus 2. Same thing in both brackets, so I've done this right, factorize that bracket out, that x plus 2, which is common to both, and you're left with x minus 3 in the other bracket. So that gives me x is equal to minus 2, and this gives me x is equal to plus 3, and there are my two solutions to the first quadratic. Now, the second part, if it just said solve for t, looking at this, I'd be able to square that bracket out, remove that bracket there, and I'd end up getting a quadratic with t squareds and t's and numbers, and I'd solve it again. However, the hence here is telling me to look at my solution, or look at how I did the first part, because I'll be using that in the second part. So kind of use my solution to part 1 to help me do part 2. Okay, so these two solutions here are going to give me a quicker way of doing part 2. If you look at the quadratics in part 1 and part 2, you will notice that they are very, very similar. So here I have got x squared. Here I've got 2t minus 1 squared minus x minus 2t minus 1. Minus 6 equals 0, minus 6 equals 0. So they are very, very similar. The only difference being, wherever I have an x here, I have a 2t minus 1 here. But what that tells me is x is equal to 2t minus 1. Okay, so whatever solution you got for x in this first part is going to be equal to 2t minus 1. So instead of having to square that bracket out and remove that bracket there in the second part, I can just use these solutions with this fact here to solve for t much quicker. So x is equal to minus 2, so I'm going to sub that in here. Instead of x. So minus 2 is equal to 2t minus 1. So bring the minus 1 over. 1 minus 2 is equal to 2t. 1 minus 2 is minus 1 is equal to 2t. Divide both sides by 2. Minus 1 over 2 is equal to t. So there's a solution for t. I'll get my other solution for t by subbing 3 in here instead of x. So when x is equal to 3, what's going on? 3 is equal to 2t minus 1. Bring the minus 1 over. 3 plus 1 is equal to 2t. 3 plus 1 is 4 is equal to 2t. And then divide both sides by 2. So 4 divided by 2 is equal to t. So 2 is equal to t. So there's my two solutions for t for part 2. Okay, and again, it is the hence that is prompting me to use my solution for part 1 to do part 2. Okay, Now, in this one, as I said, I could have, if it didn't say hence there and it didn't give me the part 1, solved the part 2. Okay, I would have squared that out, I would have removed that bracket, I would have just got a quadratic with t's in it, and it would have given me these 2 solutions. The reason I need to learn this technique is there's some questions where that won't work, where you won't be able to do the part 2 without having solved the part 1 and kind of use this fact here. Okay, and I've got one of those examples here. So first part, again, just solve for x and it gives me a quadratic, so I'll do that. So the first part is 2x squared minus 5x minus 3. So when I'm solving that, my guide number is going to be 2 times minus 3 is minus 6. So factors are 1 and 6, 2 and 3. I'm trying to make minus 5, so the factors I pick are 1 and 6. So minus 5, so plus 1 and minus 6. Okay, tempting there to go for the 2 and 3, but don't forget your guide number is negative, so you need 1 positive and 1 negative factor. So like, yeah, minus 2 multiplied by minus 3, so minus 2 minus 3 is minus 5, but minus 2 multiplied by minus 3 is plus 6, and I'm looking for minus 6, so it's plus 1x and minus 6x here. So my 2 groups of 2 in my quadratic, 2x squared plus 1x factorize x out. And you're left with 2x plus 1 inside the bracket. Minus 6x minus 3 factorize minus 3 out, because you want positive numbers inside the bracket here. So 2x plus 1 equals 0. Both brackets 2x plus 1, so factorize that out. You're left with x minus 3. 0. So if 2x plus 1 is equal to 0, then 2x is equal to minus 1, and x is equal to minus 1 over 2. Over here, x minus 3 is equal to 0, so x is equal to 3. So there's my solution to the first equation. Now, part 2, hence solve for y. 2 times y squared minus 13 squared minus 5 on y squared minus 13 minus 3. The reason I wouldn't be able to do this without using part 1 is you have a y squared inside this bracket and then you're squaring it. So if you did that, you'd end up with y to the power of 4. Now, we don't have a way of solving equations where y is to the power of 4 yet. Okay, so I wouldn't, if I went that approach and I just squared this out and tried to solve it, I wouldn't be able to do it. I don't have a method for doing that yet. Okay, so this is where the hence is vital. Okay, so the hence, as I said, is pointing us towards part 1, and kind of it's telling us, it's, you know, really highlighting the connection between them. And if you look at the connection between them again, 2x squared, so where I have x in that first one, I have y squared minus 13 in the second one. Minus 5x, where I have x in the first one, I have y squared minus 13 in the second one. Minus 3 equals 0, minus 3 equals 0. So those two equations are in the exact same form, except wherever I have an x here, I have a y squared minus 13 here. So they are telling me that x is equal to y squared minus 13. So what I'm going to do again is sub this x in here for x, solve for y, sub this x in here for x, and solve for y. So I'll use the x is equal to 3 first. So instead of x, I've got 3 is equal to y squared minus 13. Bring the minus 13 over. 3 plus 13 is equal to y squared. 3 plus 13 is 16. So the square root of 16 is equal to y. Don't forget then, if you are solving by using square root, you need to consider the plus and minus case. And then square root of 16 is 4. So plus or minus 4 is equal to y. And then what if x is equal to minus a half? So minus a half is equal to y squared minus 13. Bring the 13 over. Bring the minus 13 over, becomes 13. So 13 minus a half is equal to y squared. 13 minus a half is 12.5, or however you want to write it. So plus or minus the square root of 12.5 is equal to y. So what's the square root of 12.5? 5 root 2 over 2, root 3.53, etc. So just pay attention to the question. Does it want it to a certain number of decimal points, or does it want it as a third? I'll write it as a third. So plus or minus 5 root 2 over 2 is equal to y. All right. So first part, got my two solutions for x. Second part, notice that similarity between the equations. So just put x equal to y squared minus 13 and subbed these answers in one at a time. It generated, you'll see, one plus or minus, so two solutions for y here and two solutions for y here. So overall 4 answers for y. That makes sense because, again, just returning to why I wasn't able to do this, if you did y squared to be squared, you'd get y to the power of 4. Just as a quadratic equation, power of 2 has 2 solutions, power of 4, we would expect 4 solutions, or up to 4 solutions. Okay, in the same way, just a linear one like 2x is equal to 8. When there's no power, I only get one solution. When it's 2x to the power of 1, I only get one solution. Power 2, you can get 2 solutions. Power x to the power 3, you can get 3 solutions. Here is my 4 solutions. Okay, and again, that was one where I needed to use connected quadratics to solve it at this stage. There's just one more thing I will do, because I think it comes up one of the questions in the book. It mightn't be obvious. I won't do this one in full. I'll just kind of point out the connection between the equations on this one. So if you get something like this, x squared minus 7x minus 8 equals 0. X to the 4 minus 7x squared minus 8 is equal to 0. First one, just solve it as normal. But just for the connection between them here, you can kind of get it from here. So you've got x here, and you've got x squared here. So what are you doing to go from the equation 1 to equation 2? Well, wherever there's an x in this one, you're putting in an x squared. Okay, so the connection between these is that x is equal to x squared. Okay, that's hard to see here, but if you remember your rules of indices, x to the power of 4, you can write that as x squared to be squared. So x squared squared 2 by 2 is 4. It's the same thing. So here I've got x to be squared, here I've got x squared to be squared. So the connection is whatever you get x in this first part, you put those equal to x squared and get your solutions for the second part. All right.